So far we have explained four different colligative properties. We have talked about vapor pressure depression, the boiling point elevation, the freezing point depression, and the osmotic pressure. What we're going to talk about in this single slide is that the trend that we have been talking about. What trend is that? Is that the higher the concentration of solute, it implies a higher effect of the colligative property. So this is a linear relationship, and to study quantitatively problems like that, it's exactly a linear. You will see that whatever property you have here whatever colligative property, typically that effect will be proportional, a constant, to the concentration of solute. Okay, so let's go through the different equations that you may see, and you will see that the core of the effect is this one, that the higher the concentration of solute in the solvent, the more remarkable will be that effect. So let's talk about vapor pressure. You have something called Raoult's law, and it says that the partial pressure of vapor, this is the vapor pressure of, specifically the partial pressure of the solvent, is proportional to the pressure that the solvent would have if it did not have the solute. Okay, so that's what this degree meaning here. So is the vapor pressure of the pure solvent. The moment you say that the solvent is 90%, okay, it means that now the pressure of the solvent is a fraction, the 0.9, times the pressure of the pure solvent. So of course it has decreased. This is why we call it vapor pressure depression. Okay, notice that you can write this as a fraction of the solvent, or you can also write it as a fraction of the solute. Hopefully you know that the fraction of the solvent, of course, is 1 minus the fraction of the solute. Fraction is this unit between 0 and 1 that talks instead of the percent is the per 1, if you will. Okay, so these two equations are equivalent. One is expressed in terms of fraction of the solute, the other one is fraction of the solvent. Okay, the other two colligative properties, the boiling point elevation and freezing point depression, talks about the same. Notice that this change, if the boiling point elevation, this should be positive, and this one should be negative. It will, in both cases, it will be positive, just so you know that the freezing point depression, there is a decrease of temperature. Okay, so make sure that you keep that into account. And in both cases, it is the same relationship. There is a constant proportional to molality. Okay, in both cases, it's a constant that is specific of that solute-solvent interaction. And so again, we are just going back to this kind of linear relationship that we explained already up here. The higher the concentration of the solute, the more remarkable will be the effect on that colligative property. And finally, you have another one, the osmotic pressure. The osmotic pressure has a linear relationship with the molarity, and in this case, because as you well know, molarity depends, it involves volume, so you want to include temperature in there. It has a linear relationship between the osmotic pressure and the molarity. Okay, these are just very simple equations that you need to sometimes apply, but behind those you have this effect that we have already explained. The higher the concentration of solute, the higher will be, or the more remarkable will be the effect of that colligative property.